in the second section, we are going to start with the filtration techniques. What the filtration techniques are available and why the water is filtered. And we will talk first about these. And obviously, when the later module come, we will discuss its operation, maintenance, design, and any question you will have. Hopefully, I will try to respond to your points. Yeah, this in the water, we are on the water treatment side now, and this green area is for the slides that we are going to discuss. First, the filtration techniques available in our industry. Mainly, I'll be covering the industrial side because on the domestic side, there are very few opportunities available, and they are very big projects, sewage treatment plant, drinking water, the filtration plants, and mostly our engineers and the professionals, they get the opportunities in the industry, utility areas, drinking water plants. And what I have observed over the year, that third world, and especially in Pakistan, people don't have the skills of the water and wastewater treatment. They even lack the basic knowledge. And especially in our country, we don't have the water institutes from where the engineers can, or the professionals, or the BTech and MSc chemistry, and then people or the diploma holders in the instrument, chemical, mechanical, they don't get they don't have the opportunity to learn about the water treatment, operation, maintenance. And all the time when I go into the industry, I see that there is lack of operators, engineers, and if they are available, they get the on-job training, and they are not the perfect, frankly speaking. They don't know the basics of the water treatment plants or the wastewater treatment plants, and they just want to operate the plant. One of my objective is that I should give knowledge to my engineers in Pakistan, especially. They can learn the water treatment, they can learn the wastewater treatment, they can understand the process. And when they go for the interviews to any industry, every industry requires the utility engineer. They require the engineer for the boilers, cooling towers, heat exchangers, water treatment, wastewater, and upcoming technologies, recycling, zero liquid discharge, the huge field in the next decade, and a lot of job opportunities coming in this area. And I have to put my lot of struggle. I've tried and raised my level to various levels to explore this opportunity, that I should invite the government and make them realize, the universities, that they should develop a course on the water and wastewater treatment technologies where engineers can learn. But unfortunately, our bureaucratic style doesn't allow us to take decisions. And rest assured, it's my commitment based on 30 years experience of Pakistani industry and the global exposure, that there are a lot of opportunities coming up for the job. If you are really interested to learn in this water and wastewater treatment techniques, I assure you these engineers can find the job in the coming years. And especially in the textile sector, and local EPA is very active, sugar sector, power sector, they all require they are going to set up the wastewater treatment plants, and finally they will go for the recycling, because they will be having water withdrawal charges from the government. And we need to understand water first. What are the processes available? What are the techniques available? And how we can treat the water? And if you get knowledge, basic knowledge, and I will try to demonstrate some plant visits as well, and to people group who I can manage to industrial tours of the wastewater or the water treatment, RO plant, softening, filtration. I will surely try to assist my participants or the engineers or the professional who are interested to develop their career in this field. Next, now the sand bed. You know, the sand filter is a very commonly used term. Like I will explain like the doctors, when you go to a doctor, when our elders go to a doctor, they say, okay, go for the CBC, complete blood test, or they ask you, go for the RFT, renal function test, like kidneys performance test, or LFT, liver function test, which have creatinine, urea, and then you see they see the white blood cells, pus cells in urine. That water analysis, like same is the case with the water treatment companies or a designer, that we need to have first of all the analysis of the water, what water composition is, and we need to install the equipment according to the problem which water that has. Is if there is a problem of the suspended solid only, then, and this range is up to 50 milligrams per liter, then we will go for the media filter, which is sand filter. And in that we have a multiple layer. We have a nozzle plate. It's a vessel. It's a basically, you can see a circular vessel. And we have another type of gravity filter, rectangular as well, but that belongs to the domestic water treatment. We will discuss in the later stages. Because the time is running short, I had the commitment with my team that engineers normally don't prefer to go beyond 1 hour of listening. They are not interested in the long courses. I will try to, almost 50 minutes are over. I will cover the next slides quickly, and surely I'm available for any assistance. In this sand filter, we see that we have a bed of sand. From the top, we have the water from where it is distributed, and from the bottom, we clean the water. And normally, we have at this place nozzle plates on the complete circumference, and these nozzles are covered with the gravel and the pebbles. And over on that, we have the filtration media, that is sand. The bed depth, it is around 700 to 1200 mm, and the filtration water outlet composition have 1 to 5 milligrams of suspended solids. We cannot remove the 100% solid, and the filtration rate depends on what micron size of particles we have at the inlet. The normal is the filtration rating, which is removed in the sand filters. They are from up to 20 to 40 micron, less than 20 micron particle size, they will pass through the filters. And similarly, the multimedia filter, they are used like sand filters. This is the same behavior, but in this case, we have an additional media bed, that is anthracite. Basically, objective of this multimedia filter is to increase the runtime, filter runtime, because in the sand filter, if we see that this is the top bed of the sand only, all the settlement or retention of the sand or suspended solid will remain on the surface of the sand. This is anthracite is a bit bigger size media, and we place a bed of anthracite so that on the top of the sand, so that we can increase the run time of the sand filter. The backwashing frequency we can reduce, and it can be operated on the higher velocity, like 15 to 25, and these are the different applications we use. And its back filters are always backwash the higher velocities than the service velocities, and I have given you some information on data. You can have it. You can have a look on that, and yeah, I will also share the presentation with you all. Then, apart from the media filters, sand filters, we have various other type of filters like brim filters with reduction of iron. Sometimes we have iron problem, we have to reduce the iron. For that, the brim filtration procedure or the filtration vessel design is almost same, that we have a from the top, the service, and from the bottom, the product, and the backwash from the bottom, and the drain from the top. Almost with minor changes in all these requirement of the media. We have the manganese green sand filters and anthracite filter, activated carbon filter for the removal of chlorine, color, odor, arsenic removal. We have that filter that will be, inshallah, we'll be discussing all these techniques when we go in our module of filtration. Now, we are coming to the next thing. First, we discuss the filtration technology. Now we are discussing overview, or rather we are having the overview of the ion exchange technology. In ion exchange technology, you can see ion exchange. Ion exchange is basically, it's now old technologies, you can say, and RO has replaced it to the maximum extent. And now the ion exchange technology, for other than the water, they have many uses. They have for the breweries and the soft drinks, household filters, processed water requirement, ultra pure water requirement. After desalination or an RO, we can have polishers, ion exchange polishers with maybe cation anions, or the mixed bed polisher, or the EDI electrodialysis systems. And in basically what ion exchange process do, that we have a vessel, it is filled with the resins. And in the first vessel, we, as you know, that we have the cations and the anions in the water. In the first vessels, we put the cation resins in the first vessel. One participant has asked what is the freeboard. If you are watching this picture, this is the free area. This is the bed depth. This is the bed depth of the resin. And when we backwash this from the back, we will give the water to expand this bed. And then we drain this water while doing the backwash. We require at least 50 to 100% of the freeboard, so that we can expand our resin bed up to the 50% or the 70% as per requirement of the design. When we fluidize the bed during the backwash, this media will expand and it's go up to the top. And if we don't have the freeboard, this media will go out and into the drain. That's reply to your question, my dear. And then this is from here. First, we remove the cations, and from the cations exchanger, we go into the anion exchanger. And from the cation exchanger, we have a decationized water, which is fed to the anion exchanger, after which we get the diamine water. In ion exchange process, where it is used, I will just give you the little idea about what are the process. It is softening for the removal of hardness, to make the water soft, especially in the boilers. We see the heat exchangers. You see the heat exchanger or the boiler tubes having scales, white scales, or the iron scales. It is yellow color, de-alkalization for the removal of the bicarbonate. You see the decationization, so that removal of cations, demineralization, removal of complete ions, mixed bed polisher we can use. After demine, we have a water, depending upon the feed water quality, we have maximum 10 TDS, 5 to 10 TDS water. If we further need polishing, we can go for the mixed bed polishers or ADI as for the making the water more distill or the clear. For the high pressure boiler use, like in the high pressure boilers, we have pressure 40, 80, 100 bars. We require conductivity of the feed water less than 0.2, which is almost, you can say, if we have 50% relation, the 0.01 TDS, just in traces. And for that, we require a mixed bed polisher or ADI. And in some water, nitrates are present. We can have a selective ion removal resin as well. Inshallah, we will discuss this in our ion exchange module. And you can see these are the picture of the softening plant. We have a battery of the softening plant which we installed at the TNB Liberty Power. It is in the Sindh area of Pakistan, and it's a 90 cubic meter per hour for automatic softening plants. And you can see this is the brine tank with which regeneration of this resin is carried out. Now we have a resin type, different type of resins available in the market, and strong acid cation resins. They remove the hardness, like calcium, magnesium. If they are in hydrogen form, they remove the cations. These are just for your information, and you must be familiar with these resins, so that when we will discuss in our ion exchange or the Riemann module, and this will, I will not go into the more details, except I will talk that SAC, strong acid cation exchange resin, weak acid cation exchange resin. The weak acid cation exchange resin, they are used for the calcium and magnesium removal from the solution of this having alkalinity, more alkalinity. Then the strong base anion resin, you see, they are basically the resin have the functional group of OH, hydroxyl form of resin, and chloride form as well, and the applications are different. Samely, we have the weak basic anion exchange resin, which are commonly called WBA.